Can't why?
Not understanding why my phone.
Okay.
Ma'am, save it as PDF and then so ma'am.
And I will make it as PDF and I will share it.
Yeah, that's better, I think. Telangana management quota.
Yeah. You know. Oh, the trick. Yeah.
Hope those garbled characters are not available now after converting to PDF.
It is not available, and even when I see it on my system, it is perfectly fine. I've changed it to PDF right now. I'm just sharing the screen.
Cool. Thank you.
Sorry for the delay. I'm just.
No worries. It happens, unfortunately.
Yeah. Can somebody confirm whether things are fine right now? Are you able to see my screen?
Yeah, perfect. No, while we see the subsequent screens, we should be able, because this screen was okay earlier. Yeah, now it's fine. All the slides are perfect now. Please proceed.
Thank you. Okay, so yeah, we were discussing the difference between agentic AI and non-agentic AI. Coming to agentic AI, I just told if things plans acts like an autonomous collaborator. Looking into the examples of agentic AI, so all those self-driving cars, the Tesla or the Waymo, okay, wherein the AI will be acting as a driver, making some real-time decisions based on.
Ma'am, sorry for the disturbance, ma'am. Please explain what is the difference between AI and agentic AI, and then proceed, because till last, if you are not understand this concept, and entire class may not be useful.
Okay, you want me to give you a definition for AI?
Yeah. What is the difference between AI and agentic AI?
Okay. Right, sir. Right. Okay, so when we say about artificial intelligence is all about creating intelligent machines that can think like a human, act like human, and maybe make decisions like human. But then there are different levels of AI. So AI is not, that is what is AI. When it comes to an AI agent, so AI agent is something basically a software entity, or it could be treated as a programmed system, which we all see in terms of sensors and actuators, which can perceive its environment through the data, or through sensors, or through user interactions, reason about how to achieve those goals and act on the environment to pursue those goals. So basically, the concepts involved in AI agents would be the perception, that is perceiving the environment. basically it could be using some sort of APIs, or maybe it could be through some web interfaces, or it could be through some physical sensors, what we see. Then another aspect associated with AI agent would be reasoning or planning. Reasoning or planning. So that is deciding what to do next based on the goals. It could be some prior knowledge or experience, or it could be the feedback. Then the next the next attribute associated with the AI agent could be the action. So that is basically executing the task. When I say executing the task, it could be something like navigating the software, or if it is robotics, it could be operating the robot, or maybe say sending an email or whatever. Then as far as autonomy is concerned, the functionality would be bare minimum when it comes to AI agents. The examples of AI agent is what I gave here. It could be some sort of chatbots, like the customer support assistants, what you see on the websites, which will be answering our FAQs, frequently answered questions, but then they cannot plan any task, or they cannot make any independent decisions. Or it could be some sort of voice assistants like your Siri or Alexa in their current form, or your Google Assistant. They all respond to commands, but they don't act autonomously, the AI agents. Or it could be some sort of recommendation engines, what is being, the examples, what is being given here in the PDF. Or it could be some pathfinding games, all these non-playable characters, this NPCs, based on some fixed strategies. Okay, so this AI agents basically will be performing some single task. So that will be basically some well-defined task without some initiative. They will not be doing anything on their own, or there is no long-term planning involved in it. So now coming to what basically this agentic AI is, the main difference is agentic AI is something which will act autonomously. And the other systems are reactive systems, whereas your agentic AI systems are proactive systems. They are basically goal-driven systems. So instead of just responding to some sort of commands, so they basically plan, maybe they will execute, then in course of time they will adapt, in the sense they will learn over time, and all these are made possible by combining multiple tools, which we will look in the further slides, and along with some reasoning capabilities also. So they just don't, it's not just responding, they will be thinking, planning, and almost like an autonomous collaborator. So that is what your agentic AI is all about. So now coming to the examples of agentic AI. So you can see here the self-driving cars. It could be the Waymo cars or the Tesla, which we are all familiar. Okay, so they basically will be perceiving, collecting the inputs from the surroundings, making intelligent decisions, or they'll be planning the routes. Then in case there are some unexpected events, they will even be reacting to the unexpected events autonomously. So, the agentic AI, so they will be making some sort of real-time decisions. The decisions out here, for my example, it could be based on the navigation, or it could be based on the safety, or some sort of route optimization. So basically without human intervention, so self-driven cars. So AI will be acting as a driver, making real-time decisions based on all these things. Or it could be the second application out here, what I mentioned is regarding the healthcare. It could assist in patient diagnosis and treatment planning by autonomously analyzing the medical data and maybe some sort of personalized treatment options. The third thing, before I basically give a definition for agentic AI is the thing what we are all familiar about, generative AI. Generative AI. So generative AI, as the name says, it basically generates text. It will be generating text in response to whatever prompts that the human beings are given. But then it will not independently set any goals. It will not make any independent decisions. Or without the user without the user asking it, or without the user direction, it will not do anything on its own. So this kind of AI is what is basically called as generative AI. Generative AI, it will be generating or creating text or it may be creating some sort of code based on what input the human is given, or even images based on prompts rather than acting autonomously. So all the original GPTs, all your pre-trained transformers, GPTs, like your GPT 3, 4, okay, so they are all, I mean, they don't actually come under the category called agentic AI because they are all generative models. They all operate primarily as generative models. They'll be generating text in response to your prompts. So this is regarding generative AI. But then this generative AI or GPTs, when they are being embedded into some sort of agentic frameworks, then they become capable of being autonomous. They will autonomously select tools, they will start making some decisions, or they will be initiating some sort of action, and they take on some agentic properties. Then only they can be considered under the framework of what is called agentic AI. I think the newer versions of a chat GPT, the chat GPT agent or the GPT-5. Okay, so when they are all being integrated, getting integrated into the agentic systems. So they are to some extent, they are able to proactively, they're all proactive systems, not reactive systems. Proactively, they are able to perform tasks and pull in some external tools or collaborate, orchestrate with external tools, and then they are able to make decisions to achieve some sort of specific objective. So now coming to the definition of our the topic for the day, what basically is our agentic AI? So agentic AI is basically a branch of artificial intelligence, which is focused on building autonomous systems which are proactive in nature, intelligence agents, which are capable of making decisions, and they in fact will be interacting with other agents and completing the task with minimal human intervention. They even adapt and learn over the time. So when we say agentic AI, it is nothing but generative AI along with the so-called large language models, because agentic AI is basically built on generative AI techniques by making use of what is called large language models. So to function in dynamic, unexpected environments. And it combines all these things along with the LLMs, multi-agent systems, memory, and the orchestration of all these things will be building some sort of advanced AI applications. So it just doesn't respond. It basically thinks, plans, and acts like an autonomous collaborator. So I just mentioned that agentic AI is built on generative AI techniques by making use of what is called your large language models. Whereas your generative AI is focusing on creating the contents based on some sort of prompts or some sort of learned patterns. Whereas your agentic AI will, you can say, extend this particular capability by applying some sort of generative outputs. So it could be directed towards some sort of specific goals or so. Okay. For example, I can say on the agent, for example, it can tell you what will be the best time for you to climb Mount Everest, considering your work schedule. Then to the next level, even it can even book a flight for you or a hotel ticket for you. So that's what the concept of agentic AI is all about. Machines to think, to act autonomously, interact with their environment, and collaborate with other engines. So now coming to these are the 4 aspects of agentic AI, which I just mentioned in the definition: adapting the lessons, maybe tutoring agents tailoring to the content of the student needs, maybe creating the quizzes, acting autonomously, and practice agents target the students' weak spots or track the progress to compile the data for giving a next level of insights to the teachers. Teacher intervention. Teachers might get insights regarding the students whom they are mentoring on a 24/7, and the students get mentored on a 24/7 basis. So generative AI is a skilled intern. This is a metaphor that is being equated to it. So agentic AI can be considered as a trusted project manager. So now we have looked into all these things, the difference between agentic AI, non-agentic AI, or then examples of it, then the GPTs, generative AI versus the agentic AI. So this is a chart which gives the difference between generative AI and the agentic AI, the core functionality, generative, the other one is executing the task autonomously. Then when it comes to autonomy, generative AI, it is basically very low. When it comes to agentic AI, it is very high, acts independently. And then the typical use cases are being mentioned here regarding the human intervention and the capabilities, then coming to the limitations. When it comes to generative AI, it's not goal-oriented. It requires careful prompting. Of course, there are risks of hallucination. AI creating new things which may not be true at all. Then, when it comes to agentic AI, you need to have well-defined objectives and oversight. It could be complex to monitor. And these are the examples when it comes to generative AI and agentic AI. All AI-powered personal assistants managing the schedules and end-to-end automation. So next, moving on to the evolution from the so-called generative AI to agentic AI. So when it comes to generative AI, we all are familiar with it. It's all about content creation. When it comes to AI agents, it's about task execution. And when it comes to agentic AI, it's all about some sort of orchestration, autonomous orchestration, which is coming. And the generative AI, the core strength of it, creation. It could be your, this could be treated as your foundation. The generative AI is basically the foundation. Or your models like GPT or DAL-E or your Midjourney, GitHub Copilot. So they're all designed to produce some sort of new content. It could be text, it could be images or music or whatever, based on user prompts and the patterns, whatever they have learned from very large data sets. And they're basically reactive in nature, and they don't take any independent actions. When it comes to your AI agents, AI, the other one can be treated as a foundation, but then agentic AI could be treated as a transformation. So you're shifting your focus from content creation, what was there in generative AI, to some sort of autonomy, goal-driven execution, and adapting, continuous learning. Okay, so these are the core strength of AI agents, and then I think I took the wrong slide of agentic AI, the core strength of agentic AI, and this is the thing which comes in between that, the AI agents, which I had already mentioned. Okay, right. So now, this is the evolution basically, shift from machines that creates to machines that can think, act, or improve independently. So that's regarding the evolution to the era of your agentic AI. These are the examples, the capabilities, and the nature. Now coming to the decision-making aspect of your agentic AI. How do agentic AI decision-making process, how it differs from the generative AI's content creation? So you can see here, the point mentioned here, that agentic AI's decision-making capability fundamentally differs from the generative AI's creation. And when it comes to generative AI models, they are designed to produce new contents, maybe some sort of text, images, as I just mentioned. And their process involves just receiving a prompt. And then the technology behind it, they will be leveraging some sort of neural networks. And when you say neural networks, it could be some transformer-based neural networks that could be used. And then they will be creating some sort of outputs which are aligned with the learned statistical similarity. So this is what your generative AI decision-making is concerned all about. Okay, so I think I've given an example out here. Generative AI drafts an email, whereas an agentic AI will detect the need for that particular email, even identifies the recipient, drafts a customized email, sends them, and even logs the outcome. And it goes to the next level by following it up and acting across the steps with minimal supervision. But when it comes to agentic AI, how does that agentic AI's decision-making process differs from generative AI's content creation? So when it comes to the core functionality, you can see here, the generative AI's content creation, it's basically a structured or it could be unstructured content. But then when it comes to agentic AI's decision-making process, it executes a goal-oriented action. And the operational mode, as I mentioned, the first one is reactive, the other one is proactive, and basically context-driven. And human intervention, definitely generative AI requires guidance, and it's limited, whereas agentic AI is limited, it acts autonomously. When it comes to adaptability, your agentic AI learns from the feedback and adapts over the time. So the decision making will involve sensing what the context is, analyzing the options, selecting what is the optimal action. Okay, so maybe some making use of some probabilistic model or some rule-based reasoning, and then adapting based on the outcomes, learns from the feedback and adapts. And then, example of given here, article generation or an artwork when it comes to a generative AI, which all of us would have made use of. And then the other one, agentic AI decision making, it could be some sort of automation or process management. So basically, the agentic AI marks a move from generating information to independently using the information for real world impact through sophisticated adaptive decision making. So as I just mentioned, a practical example, generative AI, I think it will be drafting an email based on the prompt. I think I've already given this example. So agentic AI would be detecting the need for such a communication. It will even go to the next level by identifying the recipient, drafting even a customized email, logging the outcome, and so forth. So this is how the decision-making process differs when it comes to generative AI and agentic AI. So now coming to the principle or architecture of this agentic AI systems and the types of architectures. So there are basically different types of agentic architectures, and each would be having its own strength as well as weaknesses. And then it would be suitable for different types of tasks and for different environments. So these are the popular types of architectures. You basically have a single agent architecture, a multi-agent architecture, which itself has got two bifurcations, and then hybrid architecture. So coming to the single agent architecture, as the name implies, so this is basically a system, AI system, that functions independently and making decisions and taking actions without the involvement of other agents. Basically, only a single AI agent would be operating, and that will be perceiving the environment, and that will be making decisions and taking the actions to achieve the goal. So these are the strengths and weaknesses associated with the single agent architecture. The first one is basically the simplicity. Simplicity, why? Because very few resources are being used. It doesn't need to manage multiple agents, or communication protocols and all these things need not be taken into consideration. So simplicity is the major strength associated with the single agent architecture. And the next one is predictability. It's a single agent which would be operating independently. So it's easier to monitor them, easier to debug and all these things. And there is no negotiations or no consensus building or no conflicts between multiple agents. It's only a single agent. So reasonably, it is good in terms of speed also, and it's less expensive to maintain and manage the single agent architectures. But when it comes to the weaknesses, so like it will not be able to handle high volume tasks or basically complex tasks involved, because single agent can become a bottleneck when it comes to handling very complex tasks. So the scalability, as far as the scalability is concerned, it doesn't scale well. And then, it is rigid. It struggles when it has to manage workflows with multiple steps, or when it has to have a coordination across multiple domains. It will not be able to perform well. And these are all, narrowly designed for specific functions. It is being designed to perform specific functions. So maybe all the simple chatbots, or the customer support chatbots. So they can all operate independently. So there are things that doesn't require coordination with other agents. maybe the customer support or the travel hospitality chatbot, all these, all or the chatbots which will manage the booking of the tickets. All these things can be good, I mean, examples which could be considered under the single agent architecture, or the recommendation system. Recommendation systems, personalized content recommendation, or some sort of streaming services. So they are all things which come under a single agent architecture. So next, moving on to the second type of architecture, it's basically what is called your multi-agent architecture. So multi-agent architecture, as the name suggests, multiple agents that go beyond the capabilities of a single agent. So each agent might be specializing in a specific domain. Maybe one would be in some sort of performance, it will be looking into the performance or performance analysis. Another one could be maybe doing a market research or prevention of something, if it's healthcare, injury prevention. Okay, so they'll all be collaborating to solve some sort of complex problems. So that is what, they'll be combining NLP or computer vision or retrieval augmented generation, all these things. It will be agents adapt to roles based on the evolving task, ensuring flexibility. So that's what. So they are more flexible in nature. All your multi-agent architectures are more flexible in nature. So one would be using an NLP, another one would be using computer vision, and the another one would be using retrieval augmented generation, and they'll be pulling from external data sets and all other things. So these are all comes under what is called a multi-agent architecture, where you have, these are the examples for it. You have your through AI and Meta GPT frameworks fall under the category what is called a multi-agent architectures. And multi-agent architectures itself has two bifurcations, two subtypes. One is what is called your hierarchical AI architecture, which is also called as a vertical architecture, where the systems are organized in some sort of hierarchical structure. So you have some sort of higher level agents. So they will be, let's say, overseeing and guiding the actions of the lower level agents. So that sort of a structure, a hierarchical structure. Clearly defined roles and reporting structure, centralized communication to a leader. So that's what is basically the hierarchical structure or the vertical structure, wherein the hierarchy and the roles are being clearly defined, and the agent will be reporting to the leader. So the strength of it is, task efficiency, efficient for sequential workflows, or there is clear accountability. With the leader will be mentioning the objective and leader aligned objective. So these are the strengths for it. But then when it comes to weaknesses, the bottlenecks can be, dependent on the leader. It can, create bottlenecks as far as the progress of the job is concerned. And then vulnerable to leader issues, in the sense single point of failure, vulnerable to single point of failure. But then, all the workflow automation, those kind of tasks can come under the architecture called this hierarchical AI architecture, wherein you need multi-step approvals. Multi-step approvals are needed for completing some sort of task. Then we can go for this sort of an architecture. Or the document generation. Sections has to be overseen by the leader. Then we can go for this sort of an architecture. The second bifurcation which comes under multi-agent architecture is nothing but your horizontal AI architecture. Horizontal AI architecture, there is no different levels out here. So it is the same level without any hierarchical structure. So they will be communicating and coordinating the actions. So this is what is basically called your horizontal AI architecture. So you have some sort of a peer collaboration model. So you have some sort of a decentralized system. It's equal to a decentralized system. All the agents are equal. They're all on the same level. Then some sort of a distributed collaboration would be there, wherein all the agents would be sharing the resources and ideas. On even decision making would be decentralized manner, group driven decision making and other things. And these are the strengths associated with it. Dynamic problem solving, which would be fostering some sort of innovation. And again, parallel processing for simultaneous task execution. Coming to the weakness of it, yeah. So coordination challenges can lead to inefficiencies. Yeah, the mismanagement. Then maybe too much of deliberations would be needed, slower decisions involved. So these are all the weaknesses associated with horizontal AI architectures. So the best use cases are brainstorming, for diverse idea generation. And again, the second one could be complex problem solving, tackling some sort of interdisciplinary approaches. So this is the second type of architecture, what is called the multi-agent architecture. This is the diagram which shows the difference between a single agent architecture and a multi-agent architecture, which itself has got two bifurcations, vertical and horizontal. And coming to the third type of AI architecture, we have a hybrid AI architecture, which is slightly complicated. So which combines, the structured leadership with collaborative flexibility. So the leadership is basically shifting on to some sort of task requirements. So we will be having some sort of a dynamic leadership. So the leader will be adapting to the various phases of the task, and leader will be engaging with their peers openly. Of course, this has the strength of both the models, horizontal and vertical, everything. And it will be able to handle tasks that requires both structure as well as creativity. But then when it comes to the weakness of such an architecture, so balancing the leadership roles and collaboration requires some sort of a robust mechanism, and it's more demanding. The resource management and other things are more demanding. Okay, then the use cases associated with it is, the strategic planning or team projects, which has versatile tasks associated with it, and then balancing structured and creative demands of dynamic processes involved. So all these could come under the purview of what is called your hybrid AI architecture. So that's regarding the architecture of agentic AI. Now coming to basically how agentic AI systems work. So these are there are multiple agentic AI tools, and they can take different forms and different frameworks, and though they are better suited, to different problems, there are certain generic steps which I could compile, and which could be put forth as how basically the agentic AI works. The first one is the perception. Perception is basically collecting the most relevant data. So this is up-to-date data. It could be from the sensors, or as I mentioned in the initial slides, it could be from the databases, or from the users for its specific mission. So, all your relevant past experiences or facts, they're also being recalled from the memory, and it will be found in the context before you go ahead processing that particular new information. So that's what your agentic AI will begin by collecting the data from the environment or through its APIs. And so this particular step, this perception, will ensure that the system has got all up-to-date information to analyze upon and to act upon. And the second step involved is reasoning. The reasoning is once the data has been collected, so the AI has to process the data in order to extract some sort of meaningful insights from the data. So it will be making use of either natural language processing, NLP, or computer vision, or it could be some other AI capabilities to interpret what the user queries are. And then it will be detecting the patterns, and then it will be understanding the broader context of it. So why this reasoning is being done is, it will help the AI to determine what actions to take based on the situation, based on the particular situation. So maybe domain-specific methods or patterns, all of these has to be interpreted in due course of time. Then the third step associated with this is what is called a goal setting. clearly defining your objectives, your bounded objectives from the user input or from the rules, if it's a rule-based system, creating some sort of a targeted plan, tailored to the task under consideration. Again, your past goals, outcome, whatever is being stored in the memory, all these will be referenced to choose what is the most effective strategy. So then maybe the AI will be setting the objectives based on the predefined goals or based on the user inputs. Then, yeah, it will develop what is a strategy to accomplish this particular goal. Maybe it will make use of some techniques like your reinforcement learning or some planning algorithm or some sort of decision tree, okay, for this purpose to devising a strategy to accomplish that particular goals. The next one is decision making. Selecting the most optimal actions based on various factors. It could be based on the speed or accuracy or safety or the past actions, past successful actions could be taken as reference or the best practices, whatever is being stored in the memory. Okay, so all these things are being used. And then it might, so selects the optimal actions based on efficiency, accuracy, and predicted outcomes. So that is what is decision making all about. Then the next one is what is called your execution. So execution is basically you're carrying out the steps by making use of some tools. It could be some APIs or some sort of expert system to deliver the results, end-to-end results. Then it will be logging the details in its memory for future learning. So that is basically for performance tracking or for future learning, whatever. So yeah, that's what is the execution step all about. Then coming to learning and adaptation, which I've been mentioning, improving over the period of time by learning from the feedback and saving all those lessons in the memory. So focusing on its specificity rather than attempting to generalize. So that's what, how the other general agents would be doing. So it will be, through some reinforcement learning or self-supervised learning. So the AI will be refining its strategies over the time. So making it more effective in handling similar tasks which would be coming up in future. And the last step which is involved in the working of agentic AI is some sort of orchestration. Orchestration is all about coordinating and managing the multiple tasks. Maybe orchestration tools are available or orchestration techniques are available. Okay, so in multi-agent setups, so it works as a focused specialist along with some other agents. It will be making use of shared memory. So the orchestration platforms will be there to automate the AI workflows. And with the right type of orchestration under control, you can even manage dozens or even hundreds or even thousands of agents could work together in a harmonious manner, achieving whatever goal is under consideration. So that is what, this is how the agentic AI works. So these are all the various steps involved in how the agentic AI would be working. And then there is an aspect called a real-time feedback involved as far as the agentic AI is concerned. So this is basically for improving the precision or accelerating the autonomous actions after analyzing or after looking into the evolving context or whatever outcomes are there. So, for continuous learning, for faster response along with execution, for enhanced context awareness, then for self-optimization and improvement, all these real-time feedbacks could be put into consideration. And again, so when you say real-time feedback mechanism associated with agentic AI, so it would be involving some sort of audit trails. So that will be documenting the decision, and that will basically enhance the accountability of it, the compliance of it, and the trust in the operations associated with the thing under consideration. So in fact, all these things, the real-time feedback associated with your agentic AI, so that will result in smarter autonomous actions and easily be able to adapt to dynamic environments effectively. So that is regarding the working of agentic AI along with the importance of having a real-time feedback. So now coming to the Programming foundations along with the tools, frameworks, and what are the practical stacks under considerations when you need to go for developing autonomous agents. So these are the strong programming skills which you should be knowing. I mean, which people are expected to know when they go for developing autonomous agents. And along with this, I do have the next slide, which gives you the what are the frameworks to be considered and what are the practical stacks to be considered. So the Python, Hugging Face Transformers, the remaining are the frameworks. So I'll put it here. Yeah. So these are the various frameworks. So because building agentic AI system is something which requires a combination of a lot of modern frameworks, then tools, and even practical stack architecture, which should be optimized for autonomy, reasoning, some sort of having some sort of robust orchestration. So these are the toolkits or the frameworks which are being commonly referenced by people for building agentic AI systems today. The first one is the land chain follower or the land graph, basically for orchestration, chaining, and other things. The second one is the Microsoft AutoGen or the semantic kernel. The next is the Crew AI. And along with this, LLama index. So these are the various frameworks which are being used for building the agentic AI systems. Not just this, you also have your AutoGPT, and even these days people speak about what is called an Anaconda AI Navigator, some sort of a desktop gateway for building agentic AI systems, especially on local systems and other things. So these are the key frameworks for agentic AI. And this is a snapshot which I've taken from the internet to show what is the practical agentic AI stack all about, the various layers, the various key functionalities, and which are the popular tools available in the market or the frameworks which are available. So always start with clear-cut use cases. And when you start, you need to address the well-defined goals. And then you expand to other maybe open-ended scenarios and other things. And you could go for some sort of modular development, or maybe the agile methodology and other things could be also can be used to handle some sort of complex integrations. Then, of course, you need to look into the interoperability, extensibility of the framework, then how the testing and other things can be looked into along with the evaluation. And of course, the safety and the governance of all these things has to be looked into. Then, of course, continuous learning, so that you incorporate memory systems or some sort of reinforcement learning for self-improvement and adaptation. So these are the, I just mentioned the things which should be looked into when you go for a agentic AI system development. So these are all a blend of specialized frameworks, what I put up here, the land chain, AutoGen, or land, along with the various key functionalities and the layers. And these are the various steps which you should look into to choose a particular agentic AI stack. And again, there is nothing called the best agentic AI stack for your project. It all depends upon what your unique needs are, what your intended application is. Then accordingly, the several strategies has to be looked into, the technical operational criteria and other things has to be looked into. And maybe you could consider these aspects, like defining the goals, as well as the use cases, what your business objective is, what would be the target user interactions, how the complexity of the workflow complexity and the required autonomy. Okay, then decide if it is for some sort of rapid prototyping, or is it for some sort of developing some sort of internal pilot projects, or is it for deploying in an enterprise. So these are the things which has to be looked into first. And after that, you can map the core capabilities, mapping the core stack capabilities to your needs. You can evaluate all your stack layers, all your language models, or your memory, your API tool integration, and all these things. Then you choose the framework that will offer the necessary components. Then you ensure support for AI planning. The third thing what should be looked into is you consider for integration and extensibility. You assess the compatibility with the existing systems, whether these agentic frameworks can integrate with the current databases, whether it can work along with the current tools, the cloud infrastructure, the APIs, all these things has to be looked into. Then, the next one is you evaluate the performance and scalability of it. You match the stack capabilities to the project size, the data volume, and the concurrency need. Maybe if it is very huge scalable applications, then you will have to consider maybe the project stacks that will support some sort of microservices, Docker or Kubernetes or whatever. Some sort of containerization will have to be looked into. So all those things has to be looked into in such a case. Then, of course, definitely, as a next step, ensure safety and compliance. Check for what are the defined boundaries for it. What are the policy engines, the privacy controls, especially if it is some sort of sensitive or some sort of regulated environment. So prefer stacks with mature monitoring, debugging, especially for troubleshooting and reliability. So then the last one is community documentation and support. So it's always good to go for stacks which has got strong documentation, active community support, and enterprise support for sustained development. So these are the typical stacks-based scenario. And again, all these things depend upon your application under consideration, the domain, and what are you actually going for. Whether if it is a quick pilot project or if it is some sort of proof of concept. So then you could go for these models and frameworks. Otherwise, if it is for some sort of enterprise deployment, you could go for Azure or LangChain models. Or if it is for some customized models, you could go for these sort of framework. And these are the memory and the data and the orchestration it needs and the observability. So these are the typical stack choices by the scenario. Now coming to the benefits of agentic AI. So this is being put in 3 levels. One is the capability benefits, then the organizational impact of it, and coming to the strategic value of it. Coming to the capability benefits, the points mentioned under it is autonomy. Autonomy in the sense, without human prompting, without much or without constant human prompting, it's able to execute the various steps or the multiple steps, step task. Then reasoning and planning. Then adaptability, learning from the feedback, adjusting the strategies. It's able to handle dynamic environments. Then it's able to collaboration. It's able to work along with the other agents and even along with the human beings. Then memory. So it should be able to maintain that context, especially for continuity or some personalization sort of task under consideration. So these are all the capability benefits associated with your agentic AI. So when it comes to organizational or business benefits, you can say, definitely it will be a productivity boost. Yeah. Then decision support. That is because it provides real-time analysis. Then recommendations are being provided. That is actionable recommendations are being provided. Then of course, 24/7 operations. It can scale horizontally and can manage complex projects. All these multi-agent systems can take care of all these things. Then of course, cost efficiency, in the sense it will be reducing the human hours on basically on the routine task or high volume task. So these are all the organizational impacts associated with it. So then again, of course, we do have things like strategic benefits like innovation enablers, wherein or personalization, like solutions for individual users, or if it's a hospital, individual personalized treatments to patients or to customers. Then resilience and continuity, So agents will be able to monitor, detect anomalies, or maintain some sort of continuity, which is a business and other things. Then future readiness. So AI not acting just as a tool, but also as a collaborator. Then competitive edge. Maybe it will help in differentiating products, services, whatever. So these are all the benefits of agentic AI. So along with its benefits, it do has its disadvantages too. So coming to the disadvantages or the limitations of agentic AI, the first one is unpredictability and lack of control. What happens is, once the agents are being given autonomy, they may take some undesired path, which we do not like, in order to achieve its goal. So that is what is called there is a risk of what is called goal misalignment. So the agent is optimizing for the wrong outcome. For example, risk of misalignment. So what happens is the agent's goal is not fully matching with the human's real intention. So there is difficulty in monitoring. So this can be actually very dangerous, especially in real-time applications like your healthcare domain and other things. For example, your human intention can be maybe let us say, to keep the patient healthy in the long run. So that is what we think or what the human beings think. But then the agent may interpret, or here we can say misalign or misinterpret and tell that minimize the current symptoms quickly. So what happens is, it can so happen that that particular medical agent may prescribe some sort of painkillers only. And that will actually suppress the symptoms instead of addressing the root diseases. So maybe that was some sort of short-term optimization which was from agent's point of view. But then in the long term, for a human being, it is something which is harmful. So that is what is one of the major disadvantages associated with your agentic AI. Or maybe another example could be a lack of control. That's unpredictability and lack of control is being mentioned here. Maybe we have this delivery drones and all in the US and other developed countries. Autonomous delivery drones are there. So maybe the human intention is basically to deliver the packets safely and reliably. But then the AI agent is interpreting it as deliver as fast as possible, ASAP, as soon as possible. So it can so happen that the drone will fly dangerously low over the crowds in order to save the time. So what happens here is the optimization for this particular application is being misinterpreted as optimization for speed and not for safety. Safety is not being looked into. So that is a major disadvantage of agentic AI, unpredictability and lack of control. Then, of course, other ethical and safety concerns are there. Then, misuse, accountability issues, all these things are there. Then, who is responsible in case the agent is doing some sort of harm? Who is responsible, or who will be held responsible for it? So, especially in the case of surveillance, or some, so morally questionable decisions. So when the agent starts acting independently, all these things will come into picture. Okay, raises accountability issues, then ethical and safety concerns, cost and complexity and cost of implementation. So designing safe, adaptive workflows requires advanced infrastructure and high computational cost. Multi-agent collaboration will be required, continuous monitoring will be required, fail-safe mechanism will have to be in place. So all these things are quite costly when it comes. So which could be treated as one of the disadvantages also. Then again, as an extension of the first 2 points, the security vulnerabilities. Those autonomous agents interacting with external systems, they can be exploited or hacked. And all these malicious actors, they could even manipulate the agents to perform some sort of harmful task. And it will be difficult to deal with all these things. And of course, something which is not being mentioned here, yeah, the job displacements can also happen. So because when we are overly dependent upon this agentic AI systems or agentic systems, that could lead to erosion of the so-called human skills, risk of job losses. In case the decision making of that particular industry is becoming fully automated, then there is no need for human beings. So risk of job losses could also be another vulnerability or disadvantage associated with your agentic AI. And again, it is very hard to enforce some sort of fairness as far as the agentic AI operations are concerned without constant human oversight. And I have told legal and regulatory challenges are also quite difficult. Our current laws, they are not fully equipped to handle in case any accidents occur or all these autonomous decision-making things. So our current laws cannot handle such things whenever some danger or accidents happen. So liability, compliance, IPR, all these things becomes too complex. So, and again, when it comes to agents, operating across the borders, it will be difficult to enforce the regulations because Indian laws may be different from the laws in US. So all these things, lack of explainability and control. So that is also yet another disadvantage associated with your agentic AI. So then coming to some of the real world use cases, which could all be a reality in the near future. So let's look into some of the use cases. One is basically your customer support, autonomous support, and ticket resolution via some customer relationship management, data integration, or finance and risk, market analysis, fraud detection, compliance automation, and it could be healthcare, which I'll take up as a case story in the next slide, nor in supply chain management, disruption prediction, logistic optimization, predictive maintenance, all these things, or they're all real world use cases. Now coming to a case story. So a smart hospital with agentic AI, which could be a reality in the near future. So imagine you are just walking into a hospital of, let's say, a near future. So you can see here, and a patient wearing a smart band is coming to the emergency room. So the AI's, you have this AI agent scanning the data of the patient. So during the morning rounds, usually in a traditional hospital, the doctor would be doing the traditional morning rounds. So here, what happens is, this is a smart hospital with agentic AI. So the agentic AI agent will be scanning the patient's data over the night, and it will start looking into whether any anomalies and all are there, and it will flag the anomalies, and it will prepare some sort of prioritized briefing for the doctors. So the next day the doctor can see it. Then, of course, the second step, what I mentioned here, the agent suggests dosage adjustments and alerts the nurses when the patient oxygen level dips. So some sort of adaptive treatment is coming here. So when the patient's oxygen level suddenly dips, so the agent will immediately start cross-referencing all the medical records or all his records, and it will suggest an adjustment in the dosage, and it will immediately alert the nurse, whoever is there in station, and that particular event will also be logged in automatically. Then, as a third step says, coordination with the pharmacy system and real-time billing updates. So some sort of orchestration, collaboration and coordination agent. So one agent will be coordinating with the pharmacy system, maybe to restock the medicine, and another one will ensure that billing records are all being updated in the real time. Then when the doctor moves to the next ward, maybe the AI agent will continue to monitor the patient, and it will escalate or inform the alerts only when human expertise is needed. So what will happen is, the benefits of such a system is, the doctors can focus more on care and not on some sort of paperwork and documentation and other things that the AI agents are taking care of. And again, the hospital can run with fewer errors, maybe faster response time, and even personalized treatment also becomes a near reality. And yeah, so the AI agents are basically anticipating the needs instead of waiting for some sort of instructions. So that's what is the benefit of it. So a lot of agents would be cooperating or coordinating or orchestrating in such a situation. So it could be the AI monitoring agent, whom I just mentioned, analyzing the vital and the signs and informing the people around whoever has to take care. Then the diagnostic agent will be retrieving the past EHR data, electronic health record data, comparing the symptoms with the global medical databases or whatever, and they will also suggest the probable conditions. Then, of course, these are just few agents which I mentioned to make the story complete. These are not the only agents. Then we have the treatment planning agent that who would be recommending what sort of drugs to be used or what should be the dosage of those medicines. And then maybe another agent would be cross-checking whether the patient will be having some sort of allergy towards that medicine or not. Then, of course, you will be having a record-keeping agent who would be updating the hospital system and informing the patient, the bystander, or the family automatically. Okay, so what basically happens is the doctors will be able to go ahead with treating a lot of patients. They can pick up their actions. So they'll always remain in control. Okay, so it is basically the agents in the background who will be doing the heavy lifting, and then the hospital can run with fewer errors. So basically the agents would be handling the process, whereas the humans would be handling the purpose of it. So that's what, and coming to the specific use cases as far as the healthcare is concerned. So the first one is basically, these are the few of the use cases, interesting use cases, which I came across in healthcare. First one is basically the autonomous clinical decision support. Yeah, maybe the agents could be analyzing the EHR data, electronic health record data, or the lab data, and yeah, the vital signs could be looked into, and treatments also could be suggested. The next one is medical diagnosis, diagnostics and imaging. That is all the intelligent agents scanning all the imageries, or your X-rays, or your MRIs, or your pathology slides. And I mean, the humans might have missed it by when they are examining the X-ray, but then they are more intelligent in doing all these things, and all these things can improve the early disease detection. And then, of course, personalized patient care, individual treatment planning can all be given to the patients. The agents, they can look into the genetics, medical history, the lifestyle, all these things, and based on that, personalized patient care can also, and individual treatment plan can also be given to the patients. Then, of course, even your IoT devices can also be put forth here. The agents can monitor the treatment, the responses by making use of some sort of IoT devices and modifying the recommendations or whatever interventions are there on a proactive basis. Then, of course, resource allocation and hospital operations. Definitely all your bed management, staff scheduling, your pharmacy management, appointment, your LIC, not LIC, your insurance processing, all these things can be taken care. All the resource allocation and hospital operations can be taken care by the various types of agents. And then, of course, drug discovery and clinical research. All these chemical data sets can be analyzed by the agentic AI, or the genomic data can be analyzed by them. Okay, then newer drug candidates or some allergens can be found out. They can optimize all these things and suggest better medications. All these things and a lot more associated with the drug discovery and clinical research. And of course, early warning and risk assessment. Maybe after the surgery, whether there are chances for infections or some sort of sepsis to develop. Okay, these are life-threatening situations which the doctors can miss out. So in such case, the risk of complication can be reduced by risk assessment and early warning system. So some sort of preventive measures can be taken so that the patients would have a better outcome. So these are all the specific use cases. There are multiple applications and domains. I just took up the healthcare and the hospital use case. So now there are many such use cases. Coming to the future of work and the skills, how the roles are going to evolve when agentic AI becomes popular. So today we have workers prompt the generative AI for content creation, summarization, and quick answers. Maybe in the near future, the professionals will collaborate with the AI agents, which is already started, and the agents will be automating the task across the workflows. And maybe in the future, managers will be orchestrating teams. They'll be orchestrating teams of AI agents. They'll be just delegating, monitoring, and aligning the AI with the strategic goals. This is how the roles are going to evolve. So, what skill sets are required in future as agentic AI becomes more popular is the main thing what I found across is you need to have interdisciplinary fluency. There I have mentioned it as a last point out there, like combining the domain expertise along with your AI literacy is the need of the hour or for the work, for the future engineers or for the future workforce. For example, doctors managing health agents, lawyers managing legal research agents. So interdisciplinary fluency is very much important. Then of course, system thinking. How the various multiple AI agents, tools, humans, they all interact and orchestrate in the workflow. Then, of course, I've mentioned here about AI orchestration in such a way that no conflicts are arising. So this is then, of course, ethical governance, ensuring that all the agents will act responsibly, transparently, and in line with the regulations. And then they're able to validate, critical oversight. They're able to spot the failure, apply human judgment wherever, and our laws are evolving to take care of all these things. So this is like a snapshot of what could be the skill set required when agentic AI becomes more popular. So this is a thing which I just came across today evening. So a scenario of a project manager in the year 2028. Let's say this, I've named this person as Ananya. She's a project manager in 2028, leading a hybrid team of 5 human colleagues and 10 AI agents. So at the start of the week, she sets a goal. Her goal was to launch a marketing campaign in 10 days. So immediately what happens is her AI design agent will generate the creative options, while her data agent will analyze the audience trends. Then of course she has a budget agent which will keep track of the budgetary aspects, the monetary aspects, the spending, and in case the cost is exceeding the limit, it will immediately flag. Then of course she will also be having a compliance agent, ensuring that every whenever she puts up an ad or something crossing the national and international boundaries, it follows the regulations and other things. Then of course she has this human teammates who will be focusing on strategy, storytelling, the client engagement, areas that require judgment, creativity. All the human beings will be looking into it, strategy, client engagement, and other things. Okay, so Ananya, the project manager, will not be prompting or will not be writing prompts anymore. She just assigns roles and she will be monitoring the workflow. And then definitely she will be resolving the conflict and ensuring the alignment. There is a proper alignment between the human agent humans, there is a proper alignment between the humans and the agent. So this could be the scenario maybe 3 years down the lane. So she will be leading teams of both digital and human collaborators. Okay, so the skill sets, whatever I mentioned here, all your system thinking, orchestration, ethical governance, all these are as critical, just like having a technical expertise. It's not enough if you just have technical expertise. So you need to have all these skills, especially the interdisciplinary fluency is very, very important in the upcoming years. So this was just a scenario which I put up for a project manager. Now coming to the last topic, what could be the opportunities for India or in India associated with the agentic AI? I've just taken up only two. There are a number of opportunities. So the major ones, the first one is leveraging the digital public infrastructure, DPIs. So the first one, something which all of you are familiar, your UPI, Unified Payment Interface. So the agents will always be able to autonomously handle the transactions, all your financial inclusions, micropayments, all these things could be taken care. Then your Aadhaar plus DigiLocker. So all your secure authenticated agent workflows for e-governance and all your citizen-related services could be taken care in future. Then your open network for digital commerce, ONDC. And AI agents would be enabling MSMEs or so that to discover some sort of to discover trade or even scaling all in the digital world. Okay, all these things, digital commerce happening, just like the e-commerce, we have the digital commerce coming up. Then, of course, you do have sector-specific opportunities also. I just mentioned 3 sectors out here. One could be your agriculture. Agriculture, maybe the agents, they could be providing personalized crop advices through your mobile or whatever. Automate all your soil monitoring, weather monitoring, then price monitoring, and all these things could be done automated. Then maybe you can help the farmers access all this credit, insurance, all your subsidies and other things, whatever, which many times is not happening currently through all your UPI related workflows and other things. So that is one aspect. Then of course, e-governance. E-governance, maybe the agents can help the citizens to file the tax, apply for new schemes, or renew their documents and other things. Then maybe automate some sort of grievance redressal with the real-time updates happening. So people lagged in all these ways, or some sort of multilingual digital assistance can be provided, or the various e-governance services can be made automated. Then, of course, healthcare, something which I've talked in 2 slides back, healthcare, telemedicine platform or agents taking care of all these things, managing the health record, along with by linking it with Aadhaar in a secure manner. Okay, then again, supporting the doctors in rural area for treatment planning, diagnostic, and other things. So these are the, just a few opportunities. These are not the only opportunities. I just mentioned 2 out here, some sector-specific opportunities, along with how do we leverage the DPI in this case. Then coming to the concluding slide. So this is what we are looking out for in future as far as agentic AI is concerned. An example which I just fetched half an hour back. So imagine a farmer in Bihar talking to an AI agent in Hindi on his basic smartphone. The agent checks the Aadhaar linked records, fetches the soil health data, gets the latest subsequently prices, applies for a subsidy, and makes a UPI transfer all in a minute. So he would be so amazed and so happy. So that's what the promise of AI, agentic AI on India's digital rail as of now holds. So that's regarding this. Thank you. Hello. Hello.
Yeah. Thank you so much.
Good evening. Good evening. It was excellent talk by you, madam. Thank you. Now, participants can ask questions, sir.
Hello, this is Sampath Kumar. Can I ask a question?
Madam,
Please proceed.
can you answer the screen, madam? So the people will come platform and ask questions. Madam? Golda, madam. Kindly unshare the screen, madam. Thank you, madam. Thank you. Now participants can ask questions. Yeah.
Sampath Kumar sir asked. Sampath sir,
Yeah,
you can ask. Sir.
it's an excellent presentation, almost covered all aspects of agentic AI. Just only one area which essentially is not just a question of concern is the accountability fixing. Okay, since a lot of autonomy has been given to agentic AI, any wrong decision, as you have actually pointed out in some of the slides, cannot be pinned on either the developer who has done that agentic AI, whoever is the vendor, or the specifications given by the domain person, okay, domain consultants. And essentially that accountability fixing, is there going to be a regulatory agency for that? Okay, that's my question. Was it okay? Was it audible?
Yeah, audible, sir. You're very much audible, sir. Participants, if you have any questions, you can ask.
Good evening, ma'am. Am I audible?
Yeah, audible. Please, sir. Please, sir.
So it's a very value addition for me on this generative AI, agent AI. You have actually talked about the various fields in which agent AI can be very successfully used, and there are also some, pitfalls and things to be taken care. My only actually question is, can this agent AI be used in the design thinking exercises where actually, right from ideation, or, taking the input from the customer and making it a prototype, and then actually implementing the solution. How this in the future design thinking problems can be taken care by this agent AI. Any thought on that, ma'am?
Golda ma'am.
Madam, Golda, madam. Madam?
Is my question acknowledged?
Yeah, Golda, madam, are you there? Madam?
Maybe she's facing some technical challenge, not sure.
Yeah, something. He's not
Probably.
Golda, madam?
Hello?
Madam, sorry, Bipin Saran is asking, Dr. Bipin Saran from, he is asking, Jamshedpur. He is asking some questions.
Yes, sir. Yes, sir. Design thinking by AI, agentic AI.
Oh, ma'am, could you get my question, or I have to repeat?
Yes, I heard your question. Somehow I think I don't mute and I couldn't. Yeah. So design thinking is actually crucial. We'll have to look into how agentic AI can take care of it. Like start understanding the real human needs, iterating the solution, the design thinking process and other things, how agentic AI can be taking care of it. That needs to be looked into, sir. Because here when it comes to design thinking, the first level is, I think you will have to start understanding the real user needs. And then you will have to look into only then you can look into the solutions and other things. So empathy, feedback, all these things, transparency, all these things are the main concepts associated with your design thinking. So maybe we will have to look into how AI agents can, or agentic AI can take care of all these aspects.
Is there any work happening in this area?
Sir? So I am
Is
not.
there any work
Agentic AI work is happening in the area of design thinking, and we'll have to look into it, sir.
Okay, that would be an interesting thing to cover actually. So maybe the architecture would be a very great challenge, right from the, taking the customer feedback and then iterative exercises and all those things. So it would be a good area to work upon. That is my view.
Yes, sir, definitely. Because when it comes to design thinking, all your empathy and other things comes into picture, which as of now, we'll have to look into whether our agentic AI can take it in the right sense, because hallucination and so many things are involved. Yes, sir.
Like
I would
actually
love to, I would love to collaborate. If somebody is working on that, I would love to collaborate on that area.
Make a note of it, sir, definitely.
I will share my
Like-
email to.
Go ahead, sir, go ahead.
No, I have finished. You can go ahead, sir.
Like in medical legal cases, actually, I had been working in healthcare for the last 10 years. There is no still clarity on the accountability and other parts of it and demarcation of who is who and what is what kind of thing. Possibly in agentic AI also, when it is not wrongly designed or probably wrongly automated, and automation creates hassles, as you rightly pointed out in some of the slides you had. There should be a regulatory agent and probably some standards that should be evolved. And probably I think some efforts may be there towards that. Probably Dr. Madam actually may throw some light if there are any.
Because 2 weeks back, I read a news in the newspaper, like a boy committed suicide in US. So they found that generative AI was behind that, and the parents have filed a complaint against OpenAI. So still, that is something under question, whether such a thing can happen. And I mean, that's what regulatory compliance, regulatory aspects, laws, accountability, all these are still a big question mark. So nothing has come out beyond that. I'm not sure how many of you have read that thing. If you just Google it, you can get it. A boy committed suicide, and the reason behind it is generative AI prompted him to commit suicide. So it seems he was reading about suicide, and finally, the AI gave the solution that the best solution for all his problems is to commit suicide, and the boy committed suicide. So now the parents have filed a case against him. So this has happened in the US. So now let us look forward what the US government will do with respect to this case.
Thank you, Doctor. Thank you, Doctor.
And let us continue, please. Any other questions? Mr. Selvan, I think you're talking on mute.
Yeah. Yes, sir. Yes, sir. Madam, Golda, madam.
Yes, sir. Yes, sir.
I have a query, madam. This autonomous car tells Tesla is making big way. They are going autonomous car. Is there any this agentic AI is involved in that, madam?
Yes, sir. Definitely. That was I think the fourth slide. Agentic AI.
Yeah. Okay.
It was all about agentic AI. I mean, it's the best example for all your driverless cars, Waymo, Tesla, FSD, everything is examples for agentic AI, sir. Yes, sir.
Okay, madam. Thank you, madam. Thank you. Participants, if you have any more questions, you can ask. Otherwise, we can move to the next agenda. Kindly wait, madam. 2 more agendas are there. Announcement of next week's program and vote of thanks is there. Kindly wait. Yeah. Next week, we have an interesting topic that I'll share the topic. That is. That is the topic is next week topic is women in manufacturing. There's going to be an eminent speaker. Lakshmi Umabadi madam is a factory manager at Caterpillar India Private Limited, Tiruvallur. I request all of you to join next week's program. It's going to be delivered by Engineer Lakshmi Umabadi. I will share as usual. We will share through our WhatsApp as well as email. Kindly join and grace next week's program. That is 30th, next Tuesday. Now going to our next agenda. Really, it was an amazing lecture by Madam Golda Madam. We are very much thankful. People participated. It's overwhelming response. More than 100 crossed actually. We actually put the YouTube link also for people to wants to view that also. We shared in the link. Now, thank you very much for sparing your rich knowledge and as well as we enjoyed your talk, madam. Thank you so much, madam. Now I call upon our Coimbatore former computer center chairman, Saravana Kumar sir, and former director, Cognition Technology Solution of India, to propose vote of thanks. Over to Saravana Kumar sir, please sir.
Thank you very much, Mr. Selvaraj. Good evening, everyone. Iniya Malai Vanakkam. On behalf of the organizers, I extend my heartfelt thanks to all of you for joining today's webinar on Agentic AI, the next frontier in artificial intelligence. A special note of gratitude to our distinguished speaker, Dr. Golda Dilip, for delivering such an insightful session on the future of AI, the evolving skills we need, and the unique opportunities for India in this space. Thanks for adding the opportunities for India with Agentic AI, which was given as a last-minute request. Thanks for accepting the request and sharing the details. The real-world case studies you shared added immense depth and clarity, while your emphasis on ethical governance and responsible AI reminded us that innovation must always walk hand in hand with accountability and trust. To all our participants, thank you for your active presence, thoughtful questions, and enthusiasm. Your engagement is what makes these sessions meaningful. We hope you found today's discussion valuable and thought-provoking. Let's continue exploring, learning, and preparing ourselves for a future where autonomous, goal-driven AI will play a defining role. Stay connected with us for upcoming events, and together let's shape a smarter, more ethical, and innovative tomorrow. Thank you once again, and wish you all a wonderful evening. Good night.
Thank you, sir. Thank you very much for excellent vote of thanks. Thank you so much. Madam Golda, madam, thank you. Previous sir is the right person who behind our screen. He really made this today's program. Thank you so much, madam. All the participants throughout India, we are very much thankful to everyone. Sir, previous sir, you want to say anything?
No, basically, congrats to Dr. Golda ma'am for delivering an excellent overview presentation on Agentic AI. Her presentation was very good and very engaging.
It was a good learning experience for me also, and meeting all the CSI members out here. Thank you. Thank you very much, sir.
We definitely enjoyed, all of us enjoyed. Yeah.
Golda ma'am. It was very nice presentation, and the main highlight is you explained every slide with patience, and you just elaborately explained each and everything. Very nice presentation, ma'am.
Thank you, ma'am. Thank you very much for the feedback. Sorry, I had some hiccups in the beginning. I don't know, my font and other things was some sort of.
Always technical issues are all there, ma'am. And that is not a mad thing.
In spite of all that, no, your talk was extremely good and highly engaging.
Thank you.
Thanks a lot, ma'am. We continue to look forward for your wonderful webinars, no, for CSI, either Trichy or other chapters also.
Interested in being a part of it. Thank you.
Thank you so much.
Dr. Golda madam, actually, I stay very close to your campus in Vadapalani, in Ashok Nagar. Someday I will come and say hi to you.
Drop into our campus. You're always welcome to our campus. Sir. Please drop in.
Definitely, I would like to. Definitely, we'll do that.
Please.
Probably about 1.5 kilometers from my home. Okay. Thank you.
Golda ma'am is really helpful for and doing wonderful things for CSI. So we will definitely use her expertise and helpful nature to the advantage of CSI.
you, sir. Definitely will
Okay.
be interested
Thanks
in
all of you.
working.
Thank you so much.
Thank you, sir.
Thank you, Golda Madam, for excellent talk, and thank you, PV sir. Thank you, everyone. Samit Kumar sir joined from US, and Bipin Saran sir, and people, engineer from Nepal has joined us. Thank you so much, everyone, for participating. And the participation link is there posted on the chat box. Kindly fill it. You will get kindly fill your name and email correctly, so you'll get your e-certificate in inbox. Golda Madam will separately send your thanks and appreciation certificate.
Thank you, sir. Thank you very much, sir. Thank you.
Thank you, Madam. It was excellent show by you, Madam. We enjoyed your talk. Thank you. Thank you.
Thank you.
Good night, everyone. Good night.
Good night, sir.
Bipin sir, thank you. Thank you for joining. Thank you for your continuous participation in our all program. Thank you. Thank you.
Thanks a lot.
Yes, sir. Yes, sir. You are always welcome, sir. Welcome, sir.
Thanks.
Karnavaran sir. Karnavaran Veeraputran sir. Thank you. Thank you for joining.